Example 2. This is an example of like throwing something maybe off a cliff or off of like a ledge. Okay, so the path of a stone thrown from a cliff into the river is modeled by this quadratic equation. This question also just gives you the full formula. So it's not one that you have to actually create your own formula. Okay, so x represents the distance in meters traveled horizontally. Okay, so this is going to be distance, like horizontal distance. Okay, and y is going to represent the height. Distance. Okay, above the surface of the water. Okay, so think of the water as this right here. Okay, and maybe this guy is on a cliff. Maybe the guy's right here and he's about to throw something and it's going to go like that, right into the water. Okay, so water is going to be the height of 0 because it's the height above the surface of the river. So you usually have to figure out what is like that baseline. Okay, it could be like above the ground, it could be someone throwing something off of a building, again onto the ground, onto whatever. Okay, so first question is, how tall is the cliff? So how tall or how high is the stone? Because we're going to relate it to the stone. So how high is the stone right when it's released? Okay, so the distance, the horizontal distance would be 0. It hasn't went anywhere yet. The guy's still holding the stone. So what we'd have to do, so the distance equals 0, which is x. Okay, so x equals 0. So for A, I would take the equation and I would find the y-intercept. I would find this point right here. Okay, negative 0 squared plus 5, 0 plus 84. And if we're in standard form, this number right here is always going to be the y-intercept. So not in vertex form, not in factor form, but in standard form, completely expanded, the last number, the constant, that's going to be your y-intercept. Okay, now B, at what distance is the stone when the height reaches 60? So we have height, 60, okay, and again, height is y. So this time the y equals 60. So this one's a little bit harder. So we're going to sub 60 in for y, and we are going to solve for x. We have to solve at what distance? We have to solve for x, right? So let's move the 60 over here. We'll go 0 equals negative x squared plus 5x, and we're going to have plus 84 minus 60. Okay, we always have to have this equation equate to 0 in order to solve for the x's, in order to factor it. So this time I'm going to pull out the negative sign. We're going to have x squared minus 5x, and this originally was this would equal 24, so we're going to have negative 24. So now let's actually solve for x. What two numbers multiply to negative 24 and add to negative 5? 124, 212, 6, 4, 3, 8. Ooh, 3, 8. Okay, and the negative has to be greater, so it's going to be negative 8. Okay, so because the coefficient of this trinomial is 0, we can just do product sum. So x plus 3, x minus 8 are going to be our two factors. So let's actually solve for these, okay? In factor form, we know that there is a negative sign built into this bracket. So this is going to be x equals negative 3. And this is going to be x equals 8. So here's the problem. The stone's not going backward, it's going forward. So the horizontal distance is not going to be negative. It's going to be that 8. So at what distance is the stone when the height reaches 60 meters? For B, the answer is 8. So it's going to be 8 meters. Horizontal distance of 8 meters. Okay, and this is supposed to say C. How far does the stone travel horizontally before it hits the water? Okay, so this is supposed to be C. So in my head, I'm like, okay, where does the stone hit the water? Boom, right here. Okay, so what we're actually looking for is we're looking for this distance here. So it's going to start at 0 for sure, and then we're basically just looking for this, which is the x-intercept. Okay, but that's the x-intercept of the original. So in B, we needed to sub in 60, bring it over, and then find the x-intercepts in order to solve for x. But this one is just from the original equation. So let me just clear some board. Okay, so let's start with the original equation. Y equals negative x squared plus 5x plus 84. Okay, and let's just set it equal to 0 because we want to know the x-intercepts. So in order to solve for the x-intercepts, we set y equals 0. Let's pull out that negative. So we get x squared minus 5x minus 84. That's what we're dealing with. So what two numbers multiply to 84 and add to negative 5? I'll put 86. 84 and add to negative 5. Okay, 184, 242, 328. $421, 614, not there yet. Okay, and 712. So 712 is definitely it. The difference between 7 and 12 is 5. We're going to put the negative on the bigger number. Okay, so we get 0 equals negative. And because the coefficient here is 1, we can just put x plus 7, x minus 12. X plus 7, x minus 12. So what are the two x-intercepts? Let's just change color. Okay, I get x equals negative 7 and x equals 12. So here's the thing. Can we be a horizontal distance of negative 7 when it hits the water? No, because if you threw behind him, it would probably be on this cliff, right? So the answer is x equals 12. Therefore, when the stone hits the water, the horizontal distance, let's just put HD, is 12, and this is measured in meters.